Hello everyone, welcome back to the channel. Have you ever noticed that when you log into the Facebook from a new laptop or a friend's mobile phone, Facebook immediately says new login detected or was this you? But have you ever wondered how does Facebook know that you are using a different device? Is it checking your laptop serial number? Is it checking your IMEI number? Or is it using some secret technology? Well, the answer is none of these. Today we are going to follow the entire journey from the moment you type facebook.com until Facebook starts recognizing your device. By the end of this series, you will understand how Facebook uses technologies like DNS, HTTPS, cookies, sessions, browser fingerprinting, and many other techniques to identify your device. So let's begin. Now, imagine you are sitting at a computer and you open Google Chrome. We are talking about the first step. Now you type facebook.com and press enter. Many people think that browser immediately connects to Facebook, but actually that's not what happens. Computer does not understand like facebook.com. They only understand another thing called as IP addresses. Think of it this way. Imagine you want to visit a friend. You know his name is Ram, but can you reach his house with only his name? No. You need his address. Similarly, Facebook.com is just a name. The browser first needs Facebook actual address, which is called an IP address. So, before opening Facebook, the browser starts searching for that IP. You can say this IP is like the house address of Facebook server, and this happens due to DNS resolution. Now comes one of the most important technology on the internet. It is called as DNS, which stands for Domain Name System. And you can think of DNS as the Internet Phone Book. Let's understand this with an example. Suppose your friend says, call Rohan. Can your phone call someone just by knowing the name Rohan? No. Your phone first look inside the contacts. If it finds Rohan, it gets the phone number and makes the call. DNS works in exactly the same way. When you type facebook.com, your browser asks, can someone tell me Facebook IP address? The browser does not ask only one place. It searches step by step. First, it checks its own memory. If it does not find it, it asks the Windows. If Windows does not know, it asks your Wi-Fi router. If router does not know, it asks your internet service provider DNS server. If even that does not know, the request finally reaches Facebook authoritative DNS server, which replies with the correct IP address. Only then does the browser knows where the Facebook server is located. So each step saves time. If the browser is already knows the IP address, it does not need to search again. That's why websites often open faster than second time you visit them. Now the next step, connecting to Facebook, that is the TCP handshake. Now the browser finally knows Facebook IP address. Can it send data immediately? No. First, it needs to establish a reliable connection, and this is done using TCP, which stands for Transmission Control Protocol. TCP creates a connection using something called as three-way handshake. Think of it like calling your friend. You say, hello, can you hear me? Your friend replies, yes, I can hear you. Then you say, great, let's talk. Only after both people confirm the connection does the conversation will start to begin. TCP works in exactly the same way. The browser sends a SYN message. Facebook replies with SYN plus ACK. Finally, the browser sent ACK. Now both sides knows that they are connected to each other. And then now the browser is connected to Facebook. But there is another problem. Suppose you are about to send your email address and password. Would you want everyone on the internet to read it? No, of course not. So before sending any sensitive information, the browser creates a secure encrypted connection. This process is called as TLS handshake. Facebook sends its digital certificate. The browser checks whether the certificate is genuine or not. If everything is valid, both the browser and Facebook creates a secret encryption key. From this point onward, every piece of information is encrypted. Even if someone intercepts the data, they won't be able to read your password. This is why you see the padlock sign HTTPS in your browser. Now, the browser sends its very first request to the Facebook. It says, please send me your home page. Technically, this is an HTTP GET request. Facebook receives the request and replies with the file needed to display the page. This file includes the HTML, CSS, JavaScript, then images and fonts. Your browser downloads this file and builds the Facebook login page on the server. At this point, you can finally see the email and password boxes. Notice something important. We haven't typed a password yet. Facebook only has sent the login page. The actual login process starts after you click the login button, and we'll cover that part in the next step. So up to here in today's video, we'll learn what happens before you even log into Facebook. First, the browser finds a Facebook IP address using DNS. Next, it secures the connection with TLS encryption. Finally, it requests a login page and display it on a screen. In next part, we will see what happens after you enter your email and password. We'll learn about the cookies, sessions, browser fingerprinting, and how Facebook recognizes whether you are logging in from the same device or completely new. If you found this explanation helpful, don't forget to like the video and subscribe to the channel, and I will see you in part 2. Welcome back. In the previous part, we learned how the browser found Facebook IP address using DNS, established a connection using TCP, secured with the TLS, and finally downloaded the Facebook login page. Now let's continue from the point where you enter your email and password and click on login button. Many people think Facebook simply checks the password and logs you in. But in reality, much more happens behind the scene. And let's see how. Suppose I type the following. That is the rohan@gmail.com and password my password 123. When I click login, the browser creates a request and sends it to the server. The request is usually an HTTP post request because we are sending data to the server. And the request does not contain only the email and password. It also includes many other pieces of information like your password, your email, browser information, your existing cookies, language setting, device information, and different kind of things. So since we are already using HTTPS, everything is encrypted before it leaves your computer. So even if someone intercepts the data on the network, they won't be able to read your password. Now, the request reaches the Facebook server. The very first thing Facebook does is check whether this email exists in database. Think of it like visiting a hotel. Before giving you a room, the receptionist first checks whether your booking exists or not. Similarly, Facebook searches its database. If the email does not exist, Facebook immediately returns an error saying the email you enter is not correct in an account. The login process stops there. If the email exists, Facebook proceeds to the next step. Now comes the important security concept. Many people think Facebook stores your password exactly as you type it. Actually, it does not. Instead, Facebook stores a hashed version of your password. A hash is a scrambled version of your password created using a specific or special mathematical algorithm. For example, if your password is my password 123, Facebook may store something like 9C4F7D2B and others. This is called a password hash. When you log in, Facebook does not compare your original password directly. Instead, it takes the password you enter, hashes it using the same algorithm, and compares the two hashes. If they match, the password is correct. If they don't, the login fails. This takes storing password much safer because if someone gains access to database, they won't see actual user actual password. Now, the next step is to create a session. Now let's assume the password is correct. You have got the valid credential. At this point, Facebook knows you are the legitimate user of the account. But here's an interesting question. Do you think Facebook checks your password every time you open a profile? Imagine opening Facebook and entering a password every time you click on the photos, messages, or notification. That would be very inconvenient. Instead, Facebook creates something called a session. A session is like a temporary identity card that says this user has already been verified. Facebook generates a long random session ID, for example, A92 KD81SD9, something like this. This session ID is stored on Facebook server along with details like user ID, login time, browser, operating system, IP address, device information. From now on, Facebook will recognize you using the session instead of asking you for the password again. Now, Facebook needs a way for your browser to remember this session. This is where cookie comes in. Cookies are small pieces of data stored in the browser. Think of them like a movie ticket. When you enter a cinema, the staff checks your ticket once. After that, you simply show the ticket whenever you need it. Similarly, after Facebook verifies your login, it sends cookies to your browser. Some common Facebook cookies include C user, access, or FR. Your browser stores cookies automatically. The next time you request another page, the browser automatically sends these cookies back to the Facebook. You don't have to do anything manually. This is how Facebook remembers that you are already logged in. Now, suppose you click on your profile. Does Facebook ask for a password again? No. Instead, your browser automatically sends the cookies it stored earlier. Facebook receives those cookies and check whether the associated session is still valid or not. If session exists, Facebook immediately loads your profile. If the session has expired or been deleted, Facebook redirects you back to the login page. This is why you usually stay logged in for days without entering your password again. That's the conclusion. So in this part, we learned what happens after you click the login button. First, your browser sends a login request. Facebook checks whether your email exists or not. Then it verifies your password using a hashing process. If everything is correct, Facebook creates a session and sends cookies to your browser. From that moment onward, your browser automatically sends that cookies with every request, allowing Facebook to recognize that you are already logged in. But here's the interesting part. What happens if you log in from a completely different laptop or a new mobile phone? How does Facebook know it's a different device? That's exactly what we explore in part 3, where we'll discuss about fingerprinting, device recognition, IP addresses, risk analysis, and why Facebook sometimes asks for an OTP before allowing you to log in. Welcome back. So far we have learned how Facebook verifies your password, create a session, and store cookies in your browser. Now come to the biggest question of this entire video. How does Facebook know that you are logged in from another device? Is it checking your laptop serial number? Is it reading your hard disk? Or does it somehow know your computer's unique identity? The answer is not exactly the above. Facebook does not rely on just one piece of information. Instead, it combines multiple signals to determine whether the device is familiar or new. Let's see how it does that. So let us know how Facebook decides whether the device you are logging in is a known device or not. The first thing Facebook checks is cookies. Remember from the previous video, after successful login, Facebook stored cookies like C user, access, and FR in your browser. Now imagine the situation, you open Facebook tomorrow using the same laptop and the same browser. Your Facebook or browser automatically sends the same cookies. Facebook looks at these cookies and immediately says, I have seen these cookies before. This looks like the same browser. Now imagine a different situation. You buy a brand new laptop or use a friend's computer. Since you have never logged in into Facebook on that browser, there are no Facebook cookies. Facebook notices this immediately. Does that automatically mean you are a hacker? No. It only means this browser does not have our previous cookies. So browser or Facebook starts checking other information. Cookies are just the first clue, not the final decision. Next, Facebook look at your browser information. For example, Chrome or Firefox, your operating system, Windows or Mac OS, your browser version, your operating system version. Suppose yesterday you logged in using Windows 11 and Google Chrome browser. Today you log in using Windows 11 and Google Chrome browser. That looks familiar. But imagine today you suddenly log in using Safari, MacBooks, and that's different. Again, Facebook does not block immediately. It simply adds another clue to its security analysis. Now, let us talk about one of the most interesting technique, that is the browser fingerprinting. Think about a real human fingerprint. No single finger tells your identity. Instead, the combination of all your fingerprints makes you unique. Facebook does something similar with the browser. It collects many pieces of information such as screen resolution, time zone, language, install font, WebGL information, canvas rendering, CPU, core, device memory, platform, color depth. Individually, none of these values identify you. But when they are combined together, they create a very unique browser profile. For example, yesterday I logged in using Windows 11 Chrome with the resolution of 1920 into 1080. The language was used is English and the location is Asia Kathmandu, and I had used 8 CPU core. Today, exactly the same values. Facebook thinks this is probably the same user. Now imagine today you use MacBook Safari 2560 into 1600, different font, different graphics card. The fingerprint changes significantly. Facebook becomes more cautious. Notice that browser fingerprinting is not perfect. It's only another clue. Facebook never depends upon Facebook fingerprinting alone. Another important clue is your IP address. So, every time you connect to the internet, your internet service provider assigns you an IP address. Facebook can use the IP address to estimate your location. Let's say you normally log in from Pokhara, Nepal. Suddenly, 5 minutes later, another login appears from London. Facebook immediately asks itself, can someone travel from Nepal to London in just 5 minutes? Obviously not. This is called impossible travel detection. It does not necessarily mean someone hacked your account. Maybe you are using a VPN, maybe you are traveling, but it definitely increases Facebook suspicion. Now, Facebook combines all the information it has collected. Instead of making a decision based on one factor, it calculates an overall risk score. Some of the questions Facebook may consider are the cookies missing? Is the browser different? Has the fingerprint changed? Is the IP address unusual? Is the country different? Is a VPN or proxy being used? Is this an impossible travel situation? Has this account shown suspicious activity before? Every factor either increases or decreases the risk score. Imagine Facebook calculate a score out of 100. If the score is very low, the login is considered safe. If the score is moderate, Facebook may send you an email saying, was this you? If the score is very high, Facebook asks for additional verification before allowing the access. We can call that as OTP verification. Suppose Facebook thinks the login is risky. Does it permanently block your account? No. Instead, it asks you to prove that you are really the owner. This is where two-factor authentication comes in. Facebook may send an SMS code, an email verification code, or a code from an authenticator app. If you enter the correct code, Facebook knows that even though the device is new, it's still you. The login is allowed it. If the code is incorrect or not entered, Facebook may block the login attempt. After a successful login, Facebook saves the information about the new session. That's why when you open setting, password security, where you are logged in, you can see details like browser, operating system, city, country, time of login. This information comes from the session that Facebook created during the login process. So now you know the answer to our original question. How does Facebook know that you have logged in from another device? The answer is it does not rely on just one thing. Instead, it combines many different signals. It checks your cookies, browser information, browser fingerprint, IP address, location, login history, risk score, two-factor authentication status. Only after analyzing all of this together does Facebook decide whether the login is from a trusted device or whether it should ask for additional verification or not. So the next time Facebook says, we notice you log in from a new device, you will know exactly what's happening behind the scene. If you have enjoyed this series, don't forget to like the video, subscribe to the channel and let me know what topic would you like to explore next. Thank you for watching and I will see you in the next video.